What's up, guys? Hello and welcome to the Dev Shack. In this video, we'll go through a hands-on introduction on how to create AWS resources using Terraform. This video is timestamped throughout, and you can skip right to the hands-on demo at this timestamp on the screen. Okay, let's get started. Terraform is a declarative approach to creating cloud resources using code. Instead of clicking around manually in the AWS console, you declare what you want to create in code, and Terraform figures out how to do it. Let's take a look at the Terraform workflow. So this is the Terraform workflow. You declare what you want to build in Terraform configuration files. Terraform takes the code, validates the syntax, and calls the AWS API to create resources. Terraform evaluates the dependencies between your declared resources and creates them in the correct order. For example, your VPCs before your subnets. You can see how powerful and useful this can be. You can define multiple resources once and the dependencies between them, and you have Terraform create them without you worrying about the correct creation order. You can recreate the same resources in different accounts across different regions without needing to repeat any manual actions. With that being said, let's head over and begin the setup. All right. So before you can start using Terraform to create AWS resources, we obviously need to do a couple of setup. So let's go to this link. I'll paste these links in the description down below. So this link will show you how to install Terraform on your environment. So if you scroll down here, you can see that there are installation guide for Mac OS, Windows, and Linux. So whatever OS you are on, you can just follow this to install Terraform on your environment. We also need to install the AWS CLI. So if you're on Linux, just follow this one. If you're on Mac, the same for Windows. So once you're done following these two guides to install Terraform and the AWS CLI, you can come here and just confirm that you have the correct things installed. AWS version and Terraform version. So you might get different output depending on when you are running this, but as long as you are above these, you will be fine. Okay, let's clear our screen there. So before we can do anything, we need to go back to AWS and create an access key. So an access key is how we will interact, how Terraform will interact with our AWS infrastructure. So you can just go to IAM users, select your user, and create an access key. All right. So to avoid a lot of things, just go to either here, and you see that AWS will tell you a few things. Never store your access key in plain text or in code. See, you should disable delete keys when no longer needed. So when I'm done with this tutorial, I'll obviously delete my own key. So just click next and give your key a description here. We'll call ours AWS Terraform, so that I can just know what key this is about. So we can just hit create access key. So this key will be here. It will be an access key with the secret. And then you can download this as a CSV and click done once you're done. So I will do that. I already did this, so I will not download this one. I'll just delete it when I'm done. Anyways, alrighty. So once that's done, you can go back to the CLI and say AWS configure. So this is you setting up that access key and the secret key here, and also an optional region. The purpose of doing this is setting up this environment to say any commands that are being run to interact with AWS will use this access key, this secret, and this region. Okay, we can override this later in code, but this is just the default that we are setting for our environment. All right. Okay, so let's create a directory where we want to create our AWS resources. Let's just create this and call it AWS resources. We can see it into that directory and open in VS Code. All right, so you can use any code editor of your choice. I'm just using VS Code for this one. Okay. All right, so in this directory, we can start defining our AWS resources using Terraform scripts. So Terraform will read any file we place here with a .tf extension will be a Terraform configuration file. And Terraform will try to read that file and apply those changes against whatever environment that you have defined. So a good rule of thumb is to name with intent. So if you intend to create an S3 packet, you can just say S3 packet.tf, so that whoever is reading this source code, before they even open the file, they have an idea of what's in the file. Hopefully that someone would be future you or somebody in your team. So if you want to create an ESO instance, EC2 instance, just the same. So we know that if we look at this, we can know that we don't know what's in the file, but we can know what's in these other two files. You know, this is an EC2 instance, and this is something to do with S3 packet. So that's how we define our resources in Terraform. That's like the naming convention that we will use in this tutorial. You can use whatever naming convention your team uses or whatever makes sense for you, because Terraform will treat all this as a single file when it's running. Okay, all right. So that's it for now. I'll see you in the next one. Okay, once we are done creating our directory, we can start creating actual Terraform configuration blocks. Let's just delete these. Okay, so before we start creating actual AWS resources, we first need to configure Terraform itself. So let's just say terraform.tf. Okay, so this is telling us that we are configuring Terraform. Like, this file is where we want to configure Terraform. Terraform configuration files are written in blocks. So whatever we want to define in Terraform, we define it through blocks. So since we want to configure Terraform, this block will be a Terraform block. And we can specify a couple of things here. We can specify our required version, and we require a version that's greater or equal to 1.0.0. So anything above this will be fine. Okay, and also we can specify required providers. Okay, we require AWS as the provider, since that's our cloud provider. We will also start from HashiCorp AWS, and we want the version to be the latest 6 something version. All right, so since we have this now, this is us configuring Terraform itself to say, hey, Terraform, we require this version. That's what we're working with. We also require this provider. This is our cloud provider for this project. We can define multiple providers here for different things, depending on what we want to achieve in our project. But for this is what we want to do. Okay, so you might be wondering, how do we find these providers and everything else? Okay, so if we go to Terraform registry.terraform.io, you can see this is the official Terraform registry. It will just list a couple of the handy things like your providers, your modules, and everything else that you might need to work with Terraform. So if you click on providers here, and you can see that we have a list of a bunch of providers here: AWS, Azure, GCP, Kubernetes, and so forth and so forth. So if you follow AWS, you can see that this is the page with the documentation for the AWS provider. And you can see this is the latest version. And you can see that there's a little description here. I want to point your attention to this use provider button here. So if you click this, you see that it tells you how to tell Terraform how to configure and install this provider for your application. So we can see that there is a required providers block here, and it specifies AWS, and from that source and that version, and so on and so forth. Okay, you can also come and look at the documentation for this provider. So this is a very handy provider on how to interact with AWS resources using Terraform. So whatever you want to do on AWS using Terraform, you will find that documentation here. If you want to create a DB instance, there is something like that for you. Instance. So there is something like that for you. If you want to create an EC2 instance, you just search here. Whatever you want to do, you'll find it here. All right. So this is quite handy, and you can see that there is a couple of example usages of how to use um, this provider. In our code, we use this. Okay, and you can see that there is a way to actually configure the provider here and pass a couple of things. Let's go back to our VS Code and see if you want to further configure that provider. We say provider, remember the block starts with a keyword, so this keyword is provider. What provider? This provider that we defined here, and then we can pass whatever configurations we want to pass here. We can set our region, we can set our secret, we can set our access key here. Sorry, but remember, AWS warned us about putting this in code, so we won't do that here. If you want to put new keys, we can simply go to AWS config again and paste in our new keys and our configuration, so that we don't have to hard code those values inside here. Okay, so we can just leave this block as empty. If you leave a block empty, Terraform will do nothing because there are no configurations, there are no arguments passed into this. So this is our bare minimum Terraform configuration file. So this is configuring Terraform itself. This is just an empty block in case we want to override anything in our configuration regarding our provider. All right. So that's what we need to start working with Terraform. All right. So let's just run a couple of commands here. Okay. So let's run Terraform init. You can see that Terraform is doing a couple of things here. It's initializing the backend. We'll discuss backends when we get to that point, but for now, let's just focus on what's happening. And it's initializing provider plugins. See, it's finding this plugin with that version, and it's installing that plugin in our environment. Once it's done, you can see that there's a happy message here. Let's just take a look at what happened in our directory. Okay, so a couple of things happened here. The first one is there's a .terraform folder here, and if you expand this, you can see that it specifies whatever we specified in our providers section is been downloaded and installed on our local environment. You can see that. So now we can start interacting with that provider here. We also have a Terraform log file, which is a very important file. You don't need to modify this file since it's generated every time you run Terraform init. But in this file, you will see that we have our provider there and we have our version with that constraint and a hash. So this is to ensure that whenever we run our project, we are using this version tied to this. If we change anything in here, it will be highlighted in our Terraform log file, right? Okay. So now that we have installed Terraform itself and the provider, we can start creating AWS resources, which is what we'll do in the next one. Okay, once we're done setting up Terraform, we have defined our Terraform settings and our provider here. We can now start creating AWS resources, the fun stuff. Okay, so our first example will be an S3 bucket. Let's go here and say S3 bucket.tf. Remember, we are naming with intent. So we intend to create an S3 bucket here. We call the file S3 bucket.tf. So let's go back to the registry and see how to define, what's the syntax for defining a bucket. So we can say WS3 bucket. Okay, so there is a resource, WS3 bucket. If you click that, we can see the documentation for using for creating an AWS S3 bucket in Terraform. So we can see an example usage here with a resource declaration and a type and a name. So let's just copy this and head over to our VS Code and paste this. All right. So what do we have here? Okay, so every Terraform configuration starts with a keyword. So here the keyword is resource. What are we doing? We're creating a resource. What type of S3 bucket type? What's the name within our code that we're going to use to refer to this resource? Example. So let's rename this to say nice bucket. We're creating a beautiful bucket. All right. So this nice bucket name is what we will use when we want to reference to this resource within our Terraform code itself. It has nothing to do with AWS or our cloud provider. What has everything to do with our cloud provider is defined between these two curly braces. So whatever we define here is provider specific, okay, and resource specific. So let's go and see what arguments we can pass there. We can pass the region. We can pass in a bucket. Since you can see that all of these are optional. You see, so if you don't pass the bucket name, Terraform will assign a random unique name since S3 buckets has to be globally unique. See, okay. You see that there is a bucket prefix, a force destroy. There are a lot of options here, and all of them are optional. But if depending on what you want to do, you can configure them. All right. So let's go back to our VS Code and see. We have our bucket name here. Let's just call it nice bucket. See, and then we can just say the same here. So these tags are not they're not iffy about what you want to put here. You can read more about AWS tags, resource tags in the AWS documentation. Anyways, so remember that our bucket name we have to be globally unique. So we need to make sure that there is no other bucket in the world called nice bucket, which is a very tough decision, which is a very tough name since this is already taken by somebody. I actually created a nice bucket a couple of hours ago. So let's say we want to make this a random name. So we can append a couple of characters here to make this random. Okay, so but we don't need this manually using Terraform. We can find a provider for that creates random values for us. So let's head over to the Terraform registry. Okay, registry.terraform. Let's just, yeah, there we go. And let's search for random. Here we can see that there is HashiCorp random there, and we see that this is a provider that supports the use of randomness within Terraform configs. So so we can see that this is a logical provider, which means that it works only with Terraform logic and does not interact with any other services. So this is not going to affect or touch your AWS stuff. This is only going to work within Terraform logic. So we can go to use provider and see how we can install this provider in our system. So we can just copy this section here. That's what we want to use. Since we already have a Terraform block, we can go back to VS Code and in our Terraform, tell, hey, Terraform, we need another provider here called random. See? And that's the source and that's the version. Remember that whenever we change this provider section here, we need to run Terraform. And also remember that we only have one provider declared here. And now we have two providers in our Terraform configuration. We will need to make sure that we also have the same amount of providers here. Okay, so let's go to the terminal and rerun Terraform init. So anytime you change anything in the Terraform configuration, you have to run Terraform init again to tell Terraform, hey, this is my new configuration. Can you initialize my environment to match my configuration? So if you go back to VS Code, we can see that in our Terraform log file, we have got this random provider installed now, so that we can just start using that. All right. Okay. So let's go ahead and create a random string here. Random Okay, sorry. So what we want to do is we want to create a resource. So we want to create a resource of type random. Let's use random UUID. Okay, so what's a UUID? You can say that a UUID is a universal unique identifier. So this is a 128-bit number designed to be unique. So this is globally unique. No other number that we generate will be the same as the next one. So if we go back to our VS Code, we need to use that random number into one bucket name so that we can assure that the bucket name is unique. All right. So you only need to do this for S3 buckets, by the way. They are one of the only resources that needs global uniqueness across services. Okay. So let's name our UUID bucket UUID. Okay, so we don't need to pass any other arguments to this to create a random UID. We can just get this. We can pass things if you want, but for this demo, there's no need to do that. Let's just go here and include that bucket UID in our name. So we can come here and concatenate this random ID, random bucket result. Okay, so now we have got two resources defined. The first one being an S3 bucket and a random UID. You can see something here. We first defined the bucket before we defined our UID, but we're using the UID first. So what Terraform will do, will say, oh, we need to create this first. That is up to Terraform. That is the beauty of Terraform. You don't tell it how to do things. You tell it what you want done, and it will figure out how to do it. That's the beauty of infrastructure as code. You see, so you defined your resources the way it makes sense in your head, or the way you think about things, and then Terraform will look at that and just create a single file and see what goes first, what makes sense to go first. All right. You can obviously override and force Terraform to create resources in a specific order, but for the most part, you would just rely on Terraform's intuitiveness on what to create next after what. Okay. So this is our resource declarations. And if we run Terraform right now, this is what is going to be created. Okay. So let's head over to our terminal and see how we go about creating this on AWS. Alrighty, now that we have defined these resources, we now need to tell Terraform to create these resources. Let's head over to our terminal, clear this, and the very first command that we can run is Terraform validate. So this will just validate our syntax to see if we do not make any spelling mistakes, or to see that our syntax itself is correct, our configuration is valid, right? So we have a success there, which means we are good to go. So the very one of the most powerful Terraform commands out there is the Terraform plan command. What Terraform plan does is it shows you what changes Terraform will do when you run Terraform. So we can just say Terraform plan, and then we want that plan to be saved to a file called first plan. Let's just call it first plan. And if we can see that Terraform created the plan for us. And in that plan, it is to add 2, to change nothing, to destroy 2. And then that plan has been saved as a first plan. And this is very crucial because it allows you to see before you create anything, what's happening. So this will be created, and that these are the things these are the values that will be set after Terraform is run. And then it's another resource. If we had 100 resources here, this will be a large file. So to read this in a more easy way, we can say Terraform show that plan. We want to show that plan Terraform show in JSON the first plan, output it into a plan.json file. Okay, so if you go back to our VS Code, you can see that we have got a first plan here, which is a binary. We don't need to interact with that, but we did create a plan.json file here. Let's just format this. Okay, all right. So we can see that this is a JSON of that same plan, and there are planned values here with a couple of resources. And the first resource is that with those values, and then this is another resource, and we can say that we have resource changes that are happening. What are the changes happening? We have an address of this, and it's a type of a bucket, and we want to do a change with the inaction of creation. Okay, so this is just telling us what is going to happen when we run Terraform to our environment. See, so this is very handy to do a review before you apply anything. You just go through this and see, okay, what's in this plan? You see, what exactly is in this plan? What am I what is going to happen to our infrastructure when we run Terraform in this? So a plan is very handy, and most teams will want to do this as part of their version control. They want to see what has changed, what is the plan before they can run that on their environment. Okay, so let's go back and apply this. Let's go here and say Terraform, apply the first plan. Okay, so you can see that it's creating the random UID first. See, that random UID was created with that value, and then next it started creating an S3 bucket, and then it completed creating the S3 bucket after 2 seconds, and then that's the bucket name. So if we quickly head over to AWS and buckets, hit refresh here, we can see that we have a nice bucket here that was defined in that time, and that's the bucket name that we have in our plan. That is what we created, that bucket with that random UID that was generated. So I want to draw your attention to our source code now. Okay, let me close this. So we can see that we have a new file here, which is the Terraform state. Okay, this is very useful file that Terraform and yourself can use to keep track of what is in your infrastructure, what is being managed by Terraform, what is the state of your AWS infra according to Terraform. So this gives you a detailed outlook of what's in your environment. What's the current state of your environment. So we can see that the current state of our environment is we have got a couple of resources here, and these are managed by Terraform, and this is an S3 packet with that name created by this provider. We can see the AN, we can see the bucket, we can see the domain, we can see the region, we can see everything that pertains to the bucket. We can also interact with this state on the CLI. So if we come here and say Terraform get Terraform, let's start with Terraform show. So Terraform show will read the output of the Terraform state in a short version. So it's just to tell you what is the ANN of that resource. What resource do we have? We put an S3 bucket called nice bucket. So it's just outputting, sort of like the same configuration code that was created by Terraform when we ran apply. So this is what Terraform actually gave to to AWS, and this is what we have defined in our environment. Okay, so you can also, let's clear this. You can also run Terraform state list. This is a handy command that I use every day. It just lists what are the resources currently defined in our state file. We have an S3 bucket and a random UID. We can also drill down to show a specific resource. We can run Terraform show us this. Oopsie, Terraform state show. Okay, so Terraform state show will print one specific resource. We can say this. It's a nice bucket. It's a resource type, a WS3 bucket with that name, with that with that bucket name, and everything and everything and everything. So this just allows you to see what's in your state file without going to the console. So these values are the same as the values, some of the values that are in the AWS. Some of these values are, uh, all of this is being tracked by Terraform. Okay, so if we go back to our bucket, we can see that some of these details, if we go to regional purpose bucket, okay, some of these, the AN, you know, uh, the URL, all of these are being tracked by Terraform. All right. Okay. So this is how you create a resource on AWS using Terraform. So let's see about destroying this. Okay, so ideally, when you're using the console, when you create resources, when you create a resource, you can manually delete them using these buttons. But imagine you had like 100 buckets and you want to delete them. That would take you a couple of minutes or a few seconds, depending on how fast you are. But with Terraform, you can do that in a single command. Terraform destroy. So this is the inverse of the Terraform apply command. So this will refresh the state. It will fetch what we have in the current state. So if you go to our state file, you can see that we have got all of this in our state file, these resources. And if we run Terraform destroy, it will tell us, okay, what's going to happen to that state. The plan is to also Terraform destroy or actually create a plan. The plan is to add nothing, change nothing, but destroy too. Are you sure you want to do this? Yeah, very sure. Yes. It will start destroying the package and then the UID. So if we go back to our state file, you'd see that, oh, it's now changed. Forget that. There are no resources being tracked now. Nothing's being tracked. You see? And if we go to our console and refresh this, we can see that there are no packet defined here since we did run destroy. So this just shows you how quickly you can do things consistently on the AWS infrastructure using Terraform. If we run Terraform, apply here again, let's just say apply and then do an auto approval. This will just simply spin up our environment as we have defined it. And then we'll update our state file with the new environment. Now there we have got new resources there. And if we go back to our console, we can see that we have got now a bucket here that has been defined. So you can see if we had 100 resources like VPC instances, EC2 instances, everything else will be defined just by one command. We declared it once, we can run it countless times. We can run it across environments, across regions. We can give our friend, we can give another business, we can give our clients this to run and create infrastructure in their environments. So this is the power of using Terraform to create AWS resources, to create cloud resources for that matter. In this, we're just using AWS as an example, but you can use this to create a bunch of other resources, depending on what providers you have: Azure, GCP, Kubernetes, Oracle, the whole shebang. So, okay, this is how we do things in Terraform. For the next part, we'll dive into a little bit more complex example. Here we were just showing the ropes of how to do it. So in the next one, we'll dive deeper into creating EC2 instances, VPC, networking stuff. So hang around for the fun stuff. Cheers for now. Always remember that Terraform actually creates AWS resources. So that might cost money depending on how big of a environment we span up. So at the end of each exercise, always make sure that your Terraform state is blank if you don't intend to have things running. So just remember to run Terraform destroy so that we can just clear everything and make sure that we don't have a lot of costs in running in this exercise. Okay, so clear. So if we go back to our state file, that should be empty. Yeah, now it's got no resources. And if you go to AWS, hit refresh, we can see that there are no buckets here. So always remember to run Terraform destroy. You don't want to run a to have a cost runner mock in your account. All right. Cheers. We have deleted all our created resources and our Terraform state is blank. So we'll conclude this video here. This video is part of a Terraform playlist. In the next section, we will move from the basics to defining a complete architecture on AWS using Terraform. Thank you for your time. I really appreciate your feedback or suggestions for what concepts you think I should cover, be it in AWS, Terraform, or anything software development and delivery related. Do not forget to like, comment, and hit that subscribe button. It goes a long way in supporting the work I do here at the DevShack. Bye for now. See you in the next one.